Hello students, so welcome to a new class. So this class we will be learning a new topic students, that is a very important question, effect of temperature on reaction rate. Okay, so how temperature influences rate of reaction, and from this we will be deriving an equation called as Arrhenius equation. So put the side heading, effect of temperature on reaction rate, Arrhenius equation, spelling ARRHENIUS, Arrhenius equation. Okay, and also don't forget to underline the side heading. Okay students, ready? Yes. As we all know, rate of reaction increases with increase in temperature. I think you all know that, right? So when we increase the temperature, automatically the rate of a chemical reaction also will be increased. And here one point to be underlined, increasing temperature by just 10 degrees centigrade. For example, the reaction taking place at 30, we will increase to 40. If it is taking place at 10, we will increase to 20. So this small rise in temperature by 10 degrees centigrade, we observe the rate of reaction will be doubled by this small increase in temperature. Okay, so first point you will be writing, rate of reaction increases with increase in temperature, and increase in temperature by 10 degrees centigrade doubles the rate of reaction. Okay, suppose students, if we calculate, if we consider two temperatures, generally for this the two temperatures are taken into consideration, 35 degrees centigrade and 25 degrees centigrade. The difference between these two temperatures is 10 degrees centigrade. Okay, so maintaining the temperatures like this, and if we try to calculate the rate constants at these two temperatures, okay, and if we take the ratio of these two rate constants, then we will be reaching a value which will be equal to 2 to 3. That means the rate of reaction calculated, or the ratio of two rate constants considered at two different temperatures which are differing by 10 degrees centigrade. If we do this calculation, we will arrive at the answer 2 to 3. That means the rate of reaction will be doubled or tripled. Okay, so 2 to 3, in between this we will be getting the value. Okay, and the ratio of the two rate constants at these temperatures differing by 10 degrees centigrade, we call it as a temperature coefficient. Okay, so write down below, temperature coefficient is equal to rate constant at 35 degrees centigrade by rate constant at 25 degrees centigrade is equal to, simply you can write it like this, rate constant generally we denote it with the letter K, K at 35 degrees and K at 25 degrees centigrade. The value which we get will be almost 2 to 3. Okay, so we'll put it in words. Below write down, ratio of rate constants of a reaction, ratio of rate constants of a reaction at two temperatures differing by 10 degrees centigrade, is known as temperature coefficient, full stop. So why this such small rise in temperature is increasing rate of reaction to a large extent, almost doubling the rate of reaction. Okay, so if it is 100, it will become 200. If it is 50, it will be 100. So doubling the rate of reaction with just a small rise in temperature. So for this we will be knowing the reasons, and here are two theories to give the reasons. Okay, they are collision theory and Arrhenius theory. So basing on the points given by these two theories, we will derive the equation that is Arrhenius equation. Okay students, so first what is this collision theory explaining? So collision theory is explained, first write down students, collision theory explains why such a small rise in temperature increases rate of reaction to a large extent. Full stop. According to this theory, below write down students. Point number 1. What are the points given by the collision theory? Okay. First one is collision theory. The first point given by the collision theory, write down. For a chemical reaction to take place, reactant molecules must colloid with one another. That is, there must be collisions between the reactant molecules. A simple example I will give you students. Suppose you have joined in a college. You have taken an admission in a college. Okay. So you will be given a timetable. So first class you will be going and you will be taking your seats in the respective room or the classroom provided to you. Okay. So you will sit in the classroom, and if you sit like that the whole 1 hour, will there be any friendship between the classmates? No. If you put your mouth like this and even if you don't look at each other, there cannot be any friendship. The whole year or the whole semester it will be like that only. Okay. So the same is the case with the molecules. So for a chemical reaction to take place, the reactant molecules, they should colloid with one another. Then only the chemical reaction will take place. If the reactant is like that, I don't care that reactant. Then if they don't come close together, if they don't react, if they don't collide, there will be no chemical reaction. Okay. Same is the case with you people also. If you don't talk, there will be no friendship between two students or few students in the college or school, wherever it is. Okay. Same is the first case with the reactant molecule students. The first point, write down, for a chemical reaction to take place, reactant molecules must colloid with one another. That is, there must be collisions between the reactant molecules. Point number 2. But most of the collisions between the reactant molecules are found to be ineffective. So what's the meaning? After few days, two people will become friends. Even if you talk to everyone on the first day, there will not be friendship between all the people who are there in the class. Okay. So there will be few friendships between few people. That is the relationship, a strong bond between few people. So like that here also, even though there are collisions between the reactant molecules, most of the collisions, they are found to be ineffective. Okay. And then which collision is effective? Next point, only those collisions, write down, next point, only those collisions result in a chemical reaction, in which the molecules colliding with one another, possess some amount of energy or minimum amount of energy called as threshold energy. Okay students, so first point we have seen, for a chemical reaction to take place, the reactant molecules should collide with one another. That is, there should be collisions between the molecules. But all the collisions were not found to be effective. Most of the collisions, they were found to be ineffective. Okay. And only those collisions are resulting in a chemical reaction in which the molecules which are colliding with one another, okay, they possess some amount of energy which is called as a threshold energy. Okay, spelling students, THRESHOLD, threshold energy. Underline it in the brackets. Write down its definition. The minimum amount of energy, that molecules need to possess, for a chemical reaction to take place. Okay, so this is called as threshold energy. I am not giving it you as a separate definition or a separate 1 mark question, students. Here itself we are defining. Suppose if you get in the question paper define threshold energy, then you should be able to answer that question. Okay, so the minimum amount of energy that the molecules need to possess in order for a chemical reaction to take place. Okay, next. So these are the points explained or given by the collision theory. Hope you understood, right? There must be collisions. Okay, and it was found that all the collisions taking place between the reactant molecules are not effective. Only those are effective in which the colliding molecules or the reacting molecules, they possess minimum amount of energy called as threshold energy. Okay, so next one is Arrhenius theory, students. What is this Arrhenius theory explaining, or what is this Arrhenius theory, the reasons given by this Arrhenius theory? First point, Arrhenius theory says that, first point, all the reactant molecules cannot take part in the chemical reaction. All the reactant molecules cannot take part in the chemical reaction. Like the people now, right now, how many of you are listening, sitting and taking down the notes? And I don't think so. The whole class is sitting down and listening to this lesson. Okay, so that's the way we can compare here. All the reactant molecules, they cannot take part in the reaction. If you have interest, you will definitely sit down in the class and you will listen to the lesson and you will note down the points. Right? Yes. So the first point, all the reactant molecules cannot take part in the chemical reaction. Then, which molecules will take part in the reaction? Point number 2. Only certain molecules can take part in the reaction, called as active molecules. Like some students in the class will be active, some students will be sleeping, that is they are inactive or passive molecules. Okay, so the active molecules here, how can we decide whether the molecule is active or passive? Students, we can easily differentiate one who is concentrating. Oh, this student is very much active. One who is sitting at the back bench, last bench and sleeping. We immediately give the name as the inactive students. Okay, but here in the case of molecules, how do we decide which molecule is active, which molecule is inactive? The molecules which contain threshold energy, they take part. Those molecules take part in the reaction, and we call these molecules as active molecules. And some molecules which cannot take part or which do not take part in the reaction are called as inactive or passive molecules. So write down. Only certain number of molecules can take part in the reaction called active molecules which contain threshold energy. TE is threshold energy, and some molecules that cannot take part in the reaction are called as inactive or passive molecules. So simple. Brackets which do not possess sufficient energy. Okay, which do not possess sufficient energy. Third point. There exists an equilibrium. Third point, students, there exists an equilibrium between inactive molecules and active molecules. Between inactive molecules and active molecules. Okay, next, fourth point. Have you written, students? Third point. Next, fourth point. Rate of reaction depends on number of active molecules. Rate of reaction depends on number of active molecules. Full stop. So obviously rate of reaction depends on active molecules, right? Now, as this number of active molecules increases, what happens, students? Number of collisions increases. And thus what happens? Rate of reaction increases. And thus rate of reaction increases. Point number 5, students. When there is a small increase in temperature. Point number 5. When there is a small increase in temperature by 10 degrees centigrade, passive molecules, that is the inactive molecules. So what exactly is happening to these inactive? Now we will get the reason, students, why small rise in temperature by 10 degrees centigrade is increasing rate of reaction to the large extent. Here we can get the reason for it. So passive molecules, they acquire activation energy. Okay. So what is this activation energy? The minimum amount of energy which converts a passive molecule into an active molecule is called as activation energy. Okay. So when there is a small rise in temperature just by 10 degrees centigrade, the passive molecules, they become active molecules. They will be converted into active molecules. How? By acquiring the activation energy. So what happens? Already in the system there are active molecules. Now by the rise of temperature, with the rise in temperature by 10 degrees centigrade, inactive molecules also becoming active molecules. So by which the number of active molecules whose collisions which result in a chemical reaction will also increase. Okay. So by this the active collisions will be increasing, and finally we can see that the rate of reaction also increases. So all this is happening by a small rise in temperature. So write down next point number 6, students. Thus the number of molecules having energy equal to threshold energy whose collisions Thus, the number of molecules having energy equal to threshold energy whose collisions result in a chemical reaction becomes double with a small increase in temperature. Hope you understood, students. Okay, already there are few active molecules. Now by increasing the temperature, what is happening? Inactive molecules also converting into active molecules. So the number of effective collisions increases. Okay. So next point number 7. Consequently, rate of reaction which depends on. Point number 7, students. Consequently, rate of reaction which depends on number of effective collisions. Number of effective collisions becomes almost double. With a small increase in temperature. Full stop. Okay, students. These are the points given by ARRHENIUS theory. So we have seen points given by collision theory and points given by ARRHENIUS theory. So taking all these points into consideration, below write down my last. After these points, basing on the above points, ARRHENIUS derived an equation. Basing on these points, ARRHENIUS derived an equation. Write down the equation, students. K is equal to A small letter e students, to the power minus EA, capital E, small a by RT. Write down K is equal to AE to the power minus EA by RT. Where K is rate constant, comma, E frequency factor, next small letter e exponent, next EA is called as activation energy, comma, capital R, gas constant, capital T, absolute temperature. Okay, now, so this equation we will extend students. Fine. So how we are going to do that? Taking logarithm, write down below. Taking logarithm both the sides. Taking logarithm on both the sides. Okay. Below write down. Log of k base e equals to log of k base e equals to log of a into e to the power minus EA by RT base e. Mark this as equation. Okay students, k is equal to AE to the power minus EA by RT. So what are we doing here? Taking logarithm on both the sides. Log of k base e is equal to log of a into e to the power minus EA by RT base e. Take this as equation number 1. Okay, now below write down, put a star mark and write down. But we know that log of a into b base e. Okay. So how will we write this log of a into b to base e? Log of a to base e plus log of b base e. Okay. Log of a into b is written as log of a plus log of b. Okay. Written as students. Now look here. In our equation, log of a into e is there. So we will split this. Therefore, log of a into e to the power minus EA by RT base e will be written as log of a base e plus log of e base e to the power minus EA by RT. So, taking this into consideration, applying this to our equation, this part in the equation. So, log of a into e can be split as log of a plus log of e. Till here understood now? Okay. Below write down. But we put a star mark and write. But we know that log of a to the power m students, a to the power m base e can be written as this power whatever is there, this comes in front students. So is equal to m log of a base e. This where we will apply. Look here in this log of a plus log of e to the power. So now this to this part we will apply this equation students. Okay. Log of a to the power m, log of e to the power something. So this whatever there is there in the power, this will come in front. Okay. Therefore log of e to the power minus EA by RT can be written as minus EA by RT log of e to e base e. Okay. Just apply this to this portion. So log of a to the power m base e can be written as m log of a base e. Therefore, in our expression, in our equation, log of e to the power minus EA by RT can be written as. Now this is there in the power part students. So this will come forward. Minus EA by RT log of e base e. Okay, now we will join these two. Therefore, look at equation number 1. Log of k base e is equal to log of a base e minus EA by RT log of E base E. Understood now? Okay. So this log of A into E we have split as log of A plus log of E, students. So log of E portion there is a power minus EA by RT and that power has come in front. So after taking all those things, log of K base E is equal to log of A base E minus EA by RT log of E base E. Okay. So in our expression, log of E base E is there. Anything log of 2 base 2, log of 1 base 1, log of 3 base 3. So like that the value will be equal to 1. Therefore here I have mentioned, but log of E base E value is 1. So how does this expression change now? Look here, log of K base E, log of K base E is equal to log of A base E minus EA by RT. Now we will not include this in the expression. Why? Because this value is 1. Students, we all know that conversion of base E to base 10 we multiply with 2.303. So next step is write down 2.303 log of K base 10. So here now there is no base E. Base we converted it into base 10 by multiplying with 2.303. Okay, so 2.303 log of K base 10 will be equal to 2.303 log of A base 10 minus EA by RT. Okay, just we converted base E to base 10 by multiplying with 2.303. Next comes, students, dividing on both the sides. Please write down ma. Dividing on both the sides by 2.303. Dividing on both the sides by 2.303. I think this you can do on your own. Taking the above step, dividing both the sides by 2.303. So how to write? Look at the above step, students. 2.303 by 2.303 log of K base 10 equals to 2.303 by 2.303 log of A base 10 minus EA by 2.303 RT. Next step also you can do. Okay, 2.303, 2.303 gets cancelled off. So what remains, students? So if these two get cancelled, what remains? Log of K base 10 equals to, again these two gets cancelled, log of A base 10 minus EA by 2.303 RT, and mark this as equation number 2. Okay, so just a slight change in the, students. So what did we do here? Log left side the same. Log of K base 10, log of K base 10 is equal to minus EA by 2.303 RT. I have written here, students. Just an interchange. This I brought here. That's it. So minus EA by 2.303 R, and also this T, what did I do? Into 1 by T I have written. Is there any mistake in writing like that? Okay, so if you multiply again, there will be T in the denominator, there will be EA in the numerator only. Okay, next, plus this plus log of A base 10 I have written here. Understood? I have just interchanged their positions, ma. Okay, now why I did that? Because I wanted to show that this equation is in the form of y is equal to mx plus c, which is called as a straight line equation. Y equals to mx plus c, we call it as a straight line equation. Okay, so what does this mean? It is in the form of straight line equation. Y axis, x axis. Okay, so y axis, if you take log of K base 10, x axis if you take 1 by T and plot a graph, we need to get a straight line, and also when we plotted between these two, a straight line is obtained like this with the slope, m is slope now, with the slope minus EA by 2.303 R. Okay, so from this EA can be calculated. So a simple calculation I have written here, students. So slope is equal to, What is the slope value from our equation? Minus EA by 2.303 R. Okay. Therefore, minus EA is equal to cross multiplication. 2.303 R into slope. Therefore, EA will be equal to minus will be shifted to right side. Okay. So, therefore, write down. EA is equal to minus 2.303 R into slope. Below write down, students. Activation energy can be calculated. Below write down. Activation energy can be calculated by measuring the rate constants at two different temperatures. So let us consider two different temperatures as T1 and T2. At two different temperatures T1 and T2. Okay. Now how to do this? Below write down. If K1 is the rate constant at T1, if K1 is the rate constant at T1 and K2 is the rate constant at the temperature T2, then below write down, students. Log of K1 base 10 is equal to log of A base 10 minus EA by 2.303 R T1. Okay. So, rate constant K1 at T1. Then the equation will be like this. Next, for the rate constant K2 at T2. Log of K2 base 10 is equal to log of A base 10 minus EA by 2.303 R T2. Okay. Now, this minus this. Okay. There are two equations. So, two rate constants at two different temperatures. Now, this minus this, students. So, below write down. Log of K1 base 10 minus log of K2 base 10 will be equal to log of A base 10 minus EA by 2.303 R T1. Put it in brackets minus this one. Log of A base 10 minus EA by 2.303 R T2. Okay. Now, we will solve this right hand side portion. Is equal to log of A base 10 minus EA by 2.303 R T1, EA by 2.303 R T1 minus log of A base 10 minus into minus plus EA by 2.303 R T2. Okay. Now, which will be equal to? What happened here? We have a cancel log of A base 10 minus log of A base 10. Both gets cancelled and what remains is equal to minus EA by 2.303 R T1 plus EA by 2.303 R T2. Below write down log of K1 base 10 minus log of K2 base 10 is equal to, we will put it in brackets, students, minus, write it outside, inside the brackets, EA by 2.303 R T1 minus EA by 2.303 R T2. Okay, if you open up the brackets, you should get the above step. Next, bringing negative sign to left side. So, right side there is negative sign, right? Outside the brackets. That we will move it to left side. So, what happens? Minus log of K1 base 10 minus log of K2 base 10 is equal to, now there is no minus on right side, students. Okay. So, write it without the brackets. EA by 2.303 R T1 minus EA by 2.303 R T2. Written. Next, open the brackets. Minus log of K1 base 10 minus into minus plus log of K2 base 10 is equal to. Okay. So, here if you observe here, there is one thing common. What is that? EA by 2.303 R into 1 by T1 minus 1 by T2. Below, So here is minus, here is plus. So what we will do? We will interchange. We will just reverse it. So log of k2 base 10, log of k2 base 10 minus log of k1 base 10 is equal to EA by 2.303 R into this we can write it as T2 minus T1 by T1 T2. Therefore, the last and final step, students. Therefore, okay, here it is, students. Log m minus log m by n. Therefore, log of k2 by k1 base 10 is equal to EA by 2.303 R into T2 minus T1 by T1 by T2. Okay, so put it in a box. So this will be given in the numericals. So what will be given, students? Two temperatures will be given, two rate constants will be given. We will be asked to calculate activation energy. Then we will use this expression or the formula to calculate activation energy. Okay, so draw a line till here. This is your answer for effect of temperature on rate of reaction, from which we could derive the Arrhenius equation. Okay, students. So this is all for today's class. We will meet in the next class with a new topic. Until then, take care, stay safe and bye-bye.